In this sample problem, we find that we have 15 grams of KClO3, and we're going to let it decompose. So the first thing we ought to do is balance the equation. We need a 2 in front of KClO3, a 2 in front of KCl, and a 3 in front of O2. Next, I'm going to look up the masses on the periodic table. We find that K is 39.10, Cl is 35.45, and O is 16. Now the units are grams per mole, so we ought to go ahead and write those in. The next question is asking us to find moles of KClO3, and that's our given amount. So we're going to take our 15.0 grams of KClO3, and then we need to add up the molar mass for KClO3, which we'll find is 122.55 grams per mole. And we need to divide by the mass to get our equation to work right. And we find that there is 0.122 moles of KClO3. Then to find the moles of KCl, we take our given amount of moles, the 0.122 moles of KClO3, and then we're going to multiply by the coefficient ratio found in the balanced equation of 2 moles of KClO3 to 2 moles of KCl, and we put it in to cancel out units. We'll see that we're going to multiply by 2 and divide by 2, and we come up with 0.122 moles. Then for the O2, we take our 0.122 moles of KClO3 that we started with, and the coefficient ratio for KClO3 to O2 is 2 moles of KClO3, and then 3 moles of oxygen. And again, those are found in the balanced equation. And so we take the 0.122 times 3 divided by 2 is 0.183 moles. And then to convert to grams of KCl, we take the moles of KCl, the 0.122, and we're going to multiply by the molar mass of KCl, which is 74.55. And that's found by taking the 39.1 and adding it to 35.45. And our answer for this at 0.122 times 74.55 is 9.10 grams. Then for oxygen, we take its number of moles of 0.183 moles times the molar mass of oxygen, which is 32 grams per mole. And we'll find that there were 5.86 grams of oxygen that was produced.